Welcome, colleagues. We are going to look at this question, which was a question from your test paper, test 1, about the limit. So it said evaluate the limit. So we are given this part, which was the limit as x approaches 0 for exponent 2x minus 1 over x. Then we had this other one, secant x to the power sine x. That was for the limit as x approaches 0 from the right. Then we also have the limit as x approaches infinite, natural log of x over x minus this whatever we have here is the root of x plus t minus root of x squared minus t. So I've always emphasized on this whenever you're faced with such a question which has 3 parts. So you can, the best thing is to break it into 3 parts. So you can take this part as our a. So I'll say a, let a be the limit as x approaches 0 for exponent 2x minus 1 over what? Over x. That's how best we're going to handle this question. So the first thing before you do anything for limits, just plug in the 0 where there is x, because sometimes you find that it's just giving you the answer just there and then. So if you put a 0 here, we'll have exponent 0, which is 1 minus 1. Then we'll have a 0 at the bottom, which just gives us what? 0 over 0. So this is so perfect because it shows that we can use L'Hopital's rule here. So if we differentiate the top part alone, we'll have 2 exponent 2x. That's a derivative of exponent to the power something. You differentiate the power, then you multiply it with the actual function. The derivative of negative 1 is 0, and the derivative of x is 1. So we just have this now as the limit as x approaches what? 0. So if we plug in 0 where there is x, we'll have 2 multiplied by exponent 0, which is 1. So for part A, we have 2. So now we can move on to what? To part B. So part B, I can label it as y. And we are going to say that is the limit as x approaches 0 from the right. Now we have secant x to the power sine x. So now if we apply the limit here, what is secant x? Secant x is the same as 1 over sine. Secant x is the same as 1 over 1 over sine. So 1 over sine. So let's just write it into that form, which is so nice. We have 1 over sine x to the power sine x. Now if we plug in 0 where there is x and 0 where there is x, you end up having x to the 0 to the power 0. No, this would be infinite because 1 over 0 sine x is 0, so you have 1 over infinite, which will be infinite to the power 0. Yeah, of which this one also shows that you should use L'Hopital's rule. So what can you do? What you can do about this is just introduce natural log both sides. We introduce natural log here, and we are going to also introduce. So I won't write the limit, but you should be writing the limit as you'll be writing your exams. So I'll just introduce natural log. The limit must be here. So when I introduce natural log, I have this to the power sine x. So now remember, since your first year, you know the one property of the natural log is it drops the power. So the power is going to be dropped in front of the natural log. So now we are going to have natural log y equal to sine x. I'll say natural log. Now instead of writing secant x, I'll write 1 over sine x. So here, just using analysis, you can analyze this. So if the limit is as x approaches 0, isn't it? So if I substitute 0 where there is sine here, I know that this will become 0. Then I'll have natural log of infinite. So since it will be 0 from the right, yeah, this will be infinite. So a natural log of infinite will give me infinite. But regardless, anything multiplied by 0, no matter how big a number is, when you multiply it with 0, it will give you 0. So what do we need to do? We just need to find y. How do we find y when you have natural log and a number this side? Just raise both sides by what? Exponent. Exponent 0 is 1. So we have y is equal to what? 1. So for part B, we are also done. We have found that the limit for part B is what? Is y equals 1. So now let's just go to the last part of the limit, which was that one. We had natural log of x over x minus the roots. They're saying you apply the limit as x approaches what? Infinite. So we have the limit as x approaches what? Infinite. Then we have natural log of x over x, then minus the roots. We have these roots. Yes, we have the roots x squared minus t. So I usually like seeing these as in this way. So you can see that there are two functions which are here. So you can first observe this function and then you observe the other. So yeah, for the first function, which is natural log of x over x, as the limit as x approaches infinity. This is one of the standard limit questions of which you should do not by heart. Just seeing it, you should be able to determine what the answer will be. So now if we put infinite here, there's natural log of x there. Just write it properly. We have natural log of x over, sorry, this is natural log of x. Then we have x at the bottom. So now, if you plug in infinite there, you have infinite over infinite. So which means you're supposed to use what? L'Hopital's. It will be infinite over infinite. Now, if you differentiate the top part, you're going to have 1 over x, isn't it? So that's why I'm saying that this, you just need to know that the answer will be 0 always. Because when you differentiate the bottom part, it will be 1. The top part, it will be 1 over x. Now, for applying the limit as x approaches infinite for 1 over x, it will be what? 0. So for this part, just know that it's 0. So for this part 2, there are 2 ways you can handle this. It's one of the nice things you can have. There are 2 ways you can handle this. So it is the root of x squared plus t. We have that. Then minus, we have the root of x squared minus t, isn't it? So when you have these like this, the first thing, there are 2 methods. You can either multiply the numerator, which is this one, or the denominator, which is 1, by the conjugate of this guy. Or the other way you can use factorization method, of which for me I usually really prefer factorization method. So for the first part, I'm going to factor out the x squared. So I'm going to factor out the x squared in each bracket. So when I factor out x squared here, where there is x squared here, I'll remain with 1. Then I'll have plus t over x squared. So this is what I've done for the first part. I will also do the same for the second part. So for the second part, I'll have x squared factored out. Then I'll have 1 minus t over what? X squared, like that. So the main interest about this is not changing anything, but factoring out things until you get what you want. Now, if you multiply x squared by 1, you're still going back there. The same is for that. Now, the root of x squared is x. And here, the root of x squared